Alright, let's try this again. Apparently, I had recorded the presentation, and then in the process of trying to do too many things at one time, it didn't save. So anyway, with that being said, here we go. Introductory to Chapter 9. We're going to start testing, well, we'll talk about it. So, comes up with this. I claim I'm an 80% free throw shooter. I make 80% of any free throws I shoot. So, to prove it, we go down to the gym, I shoot 50 of them, and I make 32 shots. The question is, am I exaggerating my free throw skills? So, first things first, we need to go through and we need to talk through the populations, etc. So the population is all the free throws I've ever shot. The parameter is the true proportion of made free throws. The sample is 50 free throws that I just shot just then. And then, in this case, P hat would be 32 out of 50, which obviously then comes out to be 64%. But again, the 32 out of 50 is important because when we test this, we need to go through and double check to make sure everything is, that we've got the sample size is the same. Now, the way that I was planning on having you test this is that you'd have spinners. So we'd set you up. You can also do this on TI-84s. And so you just simply spin the spinners. Oops. Let me get my point here. So you'd spin it, and then you say anything that was not in the miss area, you would say win it. So I made that one. I made that one. I missed that one. I made that one, etc., etc. So you just continue to do that for 50 times, keep track of what worked, what didn't, and then you record your data. So, now, there's only two explanations for what you're seeing. First explanation is that I am an 80% shooter. Maybe I had a bad day. We know 80% is my long-term average. I can go lower than that. Some days, if out of 50, I might be lower than that. I might be higher than that. It's kind of like flipping a coin. If I flip the coin 50 times, I'm not going to hit 25% all the time. So, that could be part of it. The other question is, the other opportunity is, I'm a liar. So either I am an 80% shooter and it didn't work out, or that 80% thing, not true. Those are your two options. Okay? So again, to do this, oops, wrong page. So then you would go through and do the simulation part over here. So you'd spin the spinner 50 times, etc. So I did one last night and I got 78%. Okay, that's better than 64. But, the question is what's correct. So then in that case, my p hat was that. So you're going to do that, and I was going to have everybody do it twice. So that would give us 40 pieces of data. So I went through, since you guys can't do the spinning, and I wasn't sure everybody was going to be there for the e-learning presentation. So here is 40 simulations. Notice I've gone down as low as 64. To be honest, I was surprised that we got that. Went all the way up to a 94. And, it's nice and normal. If you hear music in the background, it's my son's setting up a playlist, I think. So anyway, so it's right here. So again, nice and normal. The average would be kind of probably somewhere right around here between 80 and 82. Life's good. But again, we don't even care about the average of our samples here, because what we're trying to do is saying is what we're seeing unusual. So that brings us to this. Each dot, what does each of these dots represent? Each one of these dots is, think about what happened. We got each of those dots because, in theory, everybody did a sample. Okay, so, sorry, I had to pause here first. So each of these dots are based off of that spinner. So we would say each dot represents a portion of free throws made from a sample of 50 shots. And then actually it's 50 shots from an 80% shooter. So we did a simulation, each one of those represents what you would expect an 80% shooter to make. So if somebody says one dot represents a proportion of free throws made out of 50 free throws shot by Mr. Hayes, is that correct? A couple things. Did I actually shoot those? No, that was a simulation. We know that that was 80%. Do we know that I shoot 80% of my free throws, make 80% of my free throws? And the answer is no. Okay. We don't know if I'm an 80% shooter. We're testing that. The dots represent the proportion of shots made by an 80% shooter. So those dots are not mine. We're going to use those to test the theory. Am I lying or not, basically? Now down over here, what percentage of those dots represent 64 or less? We actually got one. So 1 out of 40. It's 22.5%. Okay. So interpret this percentage, and here's one of the more important parts. Oops. Okay, so assuming that I am that Mr. Hayes is an 80% free throw shooter, there is a 0.025 probability of getting a sample proportion of 64 or 0.64 or less, purely by chance. So again, what we saw, me making 64% of my baskets, if I'm an 80% free throw shooter, expected. Not really. It's only going to happen 2.5% of the time or less. So, this is going to be the conclusion. I forgot to cover that up. Based on your answer to question 8, so does the p-hat of 0.64 give convincing evidence that Mr. Hayes is exaggerating, or is it plausible that it was just a poor shot? Because the p-value is 2.5%, 0.025, and that's less than 5%, we do have convincing evidence that Mr. Hayes is not an 80% shooter. We're going to start to lay down what levels of surety we want. 90%, which is really not that sure. 95%, 99%. And it's going to be very much tied to the confidence levels of what we were doing before. But we're going to, it's going to be tied to the confidence levels, but we're coming at it in a different way. Instead of saying, this is what we're saying, if this is true, where do we expect the mean to fall, or where do we expect P to fall? Here we're saying, okay, we think this is true. We see this. What are the chances that what we saw are typical? Now, there were a couple of questions. Well, first of all, let me cover a couple things, and then we'll cover some of the questions that were asked. So, a couple things first of all. We are going to come back, and we're going to start calling these things hypotheses. So, the first one, where we assume that nothing has changed, is going to be our null hypothesis. Nothing, null. It's H sub O, and then colon, and then you're going to say that P, the true percentage, is 80%. Now, there's also going to be something else where if that's not true, what do we say? And in this case, that Mr. Hayes is a liar, so the alternative hypothesis is that I actually shoot less than 80%. One of the questions was, does it have to be less than the number that we have to? The answer is no. It's about which direction we're going. And in fact, to be honest, sometimes we kind of almost confidence interval it and kind of say, we want anything below or above a certain. And we'll start to quantify that as we go. So there's that. And then over here, we already saw the conclusion part. We also have this p-value thing going on over here. So we're going to start playing around with p-value, but instead of necessarily always looking it up, we're going to be calculating out what are the chances that what we saw are unusual. And go from there. Other questions. One of the things that I did point out was the fact that if we come back over here, okay, this alternative hypothesis, it's not saying that it's true, it's just saying that it doesn't seem like it's false. And there's a difference there, and the difference is this. It's kind of like, as I was saying, like in a court trial, right here. H of O is kind of basically saying that there's no evidence the claim is not true. So basically, it's not guilty. There's nothing there that's saying anything's unusual. We're not saying they're telling the truth, but there's nothing there saying that they're not. The alternative hypothesis is saying there is enough evidence to say what they're saying is not true. So it's kind of a guilty, not guilty thing. We're not proving innocence, we're just proving is something looking fishy or not. Some people are asking basically what the setup is and how this is a little bit different from what's going on. Basically, with the confidence interval, we did a sample size, and then we kind of calculated out where should true sample size fall in between. Here, we basically make a fixed number of trials to say if what we're saying is true, this is what we should expect to see. How is what we observed fit into what we would expect to see? So like the example here, one of the things you could test, certain cancer affects 3% of the population. It's unusual to see 5% of the staff at a local high school develop that type of cancer. If that's true, then, you know, again, true or false. You know, maybe there's a news outlet that sees 96% of people at who own Fords in Chicagoland are satisfied. National ratings say 98%. Is this unusual? Is there something about Fords in Chicago that we have to worry about? That type of thing. And then, as I said, you know, you can go both directions. So, like we ended up doing, if this is our numerical curve, we were basically saying, here's, you know, if this was going to be our 80%, here's 64%. What's the chances we see this or less? If we were saying filling cans of soda, you want to be within 12. We don't want to go too much or too little, and so we'd actually count between those two levels, and we'll cover them all of that. This was just to kind of give you a taste of where we were going. So hopefully that helps. If you have any questions, shoot me an email. Tomorrow I will post something to do this again for the first section, and then from there we'll also do something for Chapter 8 in terms of reviewing for the test, since we're not at school to do that. And I think that's it. Obviously, smash that like button, hit subscribe, hit the little bell for notifications, and we'll see you later.